Welcome back to Mr. Melling's Algebra 2. Today's lesson is talking about attributes of graphs. So we'll be talking about a couple different things: when a graph is positive, negative, when it's increasing, when it's decreasing, and when it's constant. So when a graph is positive, that means the graph is above the x-axis. Negative is when the graph is below the x-axis. And you all know the x-axis is right there. So above it is positive, below it is negative. So increasing and decreasing. Increasing is when the graph is moving up from left to right, and decreasing is when it's going down from left to right. We always read graphs from left to right. And then constant is when the graph goes left to right without going up or down. So this is a horizontal line. So just like the x-axis would be a horizontal line that is not going up or down. So those are the pretty easy basics. So we have George here. If George was to follow the path of the graph, over what intervals would he be doing the following, being positive, negative, increasing, decreasing, and constant? And so we also want to say these intervals are always open. The interval is always open. The interval is always open because, like, if you think, when is it positive? If you look, so we'll put positive in blue. It's positive everywhere here, where the graph is above the x-axis. But when it's on the x-axis, it's neither positive nor negative, so it's open. We're going to say it gets close to -5 and close to +5, but it doesn't actually touch them, so it's positive. So in parentheses from -5 to 5 for the graph. Now, it's negative, so when it's negative, we're going to put that in yellow. It's negative when it's below the x-axis. So if you look at this graph, we have our x-axis in green, and we always read the graph from left to right. So we start on the far left side where George is at. This is the part that is negative. It is below the x-axis, and we start from left to right. So this whole part is below the x-axis. Now there's also another part below the x-axis on the far right side. So to help yourself out, color that part in. So in this case, we have two different intervals that are negative. So the first one is to go from left to right, negative infinity to -5, and it's open. And then from 5 to infinity. So those are the two parts of the graph that are negative. Now, increasing. So when it's increasing, we'll put that increasing in red. So we start from left to right, it's increasing there, it's increasing here, and those are the only two spots. So we're still, even though it's increasing and it's increasing in the y value, when we're talking about intervals, we're only talking about the x values of the interval. So in this case, it's increasing. We start from left to right. It starts increasing at -infinity. That's the far left point, is -infinity. And it increases all the way to where x is -3. So even though the y value here is 4, we don't want to say it's increasing from -infinity to 4. We want to say it's increasing from -infinity to negative 3. And then the second place where it's increasing, the interval, is when x is 0 all the way to when x is 3. So from 0 to 3 is our second place where it's increasing. When we do decreasing, so we'll switch, we'll look at a purple color for decreasing. And so it's decreasing in this spot and this whole line here. So in two different locations. So in the first one on the left, it starts decreasing at negative 3. So it's not closed, it's always open, because you'll notice it's increasing all the way to negative 3, and then once it hits negative 3, it flips, and now it's decreasing as you're moving forward. So negative 3 to 0 is decreasing. And then in the second spot, from 3, and here's where a lot of people make mistakes on this decreasing, is they stop when x hits when it hits the x-axis, but we need to keep going. So it decreases from 3, 4, 5, all the way to 6. So it's going from above the x-axis to below the x-axis. That's where it's decreasing. And then finally, with constants, we'll put this one in black. Where is there a straight line? At the end. So it's constant from 6, and it continues on, because you have the arrow, to infinity. So as you look at all, that's describing every part of the graph, where it's positive, negative, increasing, decreasing, and where is the graph constant. Okay, now if you flip over your page, so give me a second here, I'm going to go to my next picture, and I'm going to have to do some editing here, so just bear with me till we get it set up. And okay, so here's our second page. So as you can see, if you look back to the first page, looking at these attributes leads us to other attributes which we will come to see all year long in Algebra 2. So the first thing that we're going to talk about a lot in Algebra 2 this year is, where does the graph cross the x-axis? And if you look at the graph, you see that it crosses it in two locations. So it crosses the x-axis when y equals 0. So if you check, when does y equal 0? First spot is at negative 5, 0. If I can write better. Let's try this again. There we go. And the second spot is at positive 5, 0. And when we're talking about points, we put them in the open brackets. So the points are listed in the open brackets. So it crosses at negative 5, 0 and at 5, 0. These are also called x-intercepts. So just remember, they're called x-intercepts. This is where the graph changes from positive to negative, or from negative to positive. And in our functions, a function can cross the x-axis in any number of times, but a function will only cross the y-axis once. So where does the graph cross the y-axis? The y-axis is when x equals 0. So if you look at your graph from the first page, it's at 0, 4. So this is also called the y-intercept. So x-intercepts and y-intercept are something we will use all year long. This is where the graph crosses the y-axis, and there can only ever be one of these in a function. So something just to commit to memory. Couple other things. Does the graph have a highest point or a lowest point that can be found? So in this case, we would say yes, it does have a highest point. It does have a highest point, so we'd say yes, the highest point is at 3, 8. So when x is 3, y equals 8, that's the highest point. That means there is a maximum value. And you'll hear me say max as we use this a lot. I'll say, what's the max of the graph? And in this case, it's the y value, which is 8. And is there a lowest value? So before you say yes, think about this. If something is going all the way down to negative infinity, you can never get to negative infinity. So if your graph goes to negative infinity, you would say there is no lowest value because it just keeps getting smaller and smaller forever and ever and ever. So there is not a minimum value, so you just say not available, no minimum value. If the graph had been reversed and had gone up to infinity, you would say there had been no maximum value. So anytime you go up or down to infinity or negative infinity, that means you're not going to have a maximum or a minimum in that direction. Alright, so just a quick practice. If George was to follow the path, and so the practice one is done in class. I drew another graph in class. I'm not going to draw it here, but if you re-look at the first one, it's the same. It's the same way. And the questions that we're going to word them, we're going to say things like, on what interval or intervals of x is f of x decreasing? F of x is the function. X is what covers the interval.